August 14th, 1942. Over the North Atlantic, 200 miles southwest of Iceland. The visibility stretched for miles across grey waters, empty save for the whitecaps that marked the endless swells rolling beneath. Second Lieutenant Elza Shahan adjusted his oxygen mask inside the cramped cockpit of his P-38 Lightning, scanning the horizon through the distinctive twin booms that framed his field of vision. Major John Weltman flew beside him in another Lightning. They had been patrolling for hours, the monotony of grey sky meeting grey sea broken only by the steady drone of twin Allison engines. Then they spotted it, a dark shape low on the horizon, growing larger. A Focke-Wulf FW-200 Condor, Germany's four-engine maritime patrol bomber, returning from a hunting expedition against Allied convoys. The engagement began when a Royal Air Force Northrop Nomad patrol bomber tracked the Condor and radioed its position. Lieutenant Joseph Schaffer, flying a P-40 Warhawk, attacked first. His machine guns found their mark. Smoke began trailing from one of the Condor's engines. Then Shahan and Weltman pushed their throttles forward, and the P-38 surged ahead with power that single-engine fighters could not match. They closed to firing range and pressed their triggers. 450 caliber machine guns and 120mm cannon per aircraft, all mounted in the nose, converged their fire on single points. The Condor's fuselage erupted in flames. The massive German bomber tumbled into the Atlantic. The American pilots circled once, confirming the kill, then turned back toward Iceland. They had just participated in destroying the first Luftwaffe aircraft shot down by United States Army Air Force's fighters. The P-38 Lightning, which delivered the final blows in this engagement, would soon earn a reputation that would force German pilots to completely revise everything they thought they knew about twin-engine fighters. What the Luftwaffe did not yet understand was that this strange American aircraft with its unconventional design would prove that two engines were not a liability in aerial combat. They were a deadly advantage. The mathematics of this transformation were already written in Lockheed's blueprints, but German fighter aces would need to learn the truth the hardest way possible: through combat. 3 months earlier, the German fighter pilot community had received reports about a new American fighter entering service. Intelligence photographs showed an aircraft unlike anything in European skies. Twin engines mounted in booms extending back from the wings. A central nacelle containing the pilot and weapons. Tricycle landing gear. The entire design violated every principle that Luftwaffe tacticians believed essential for fighter superiority. Major Adolf Galland, one of Germany's most experienced fighter leaders, reviewed the intelligence reports at Jagdgeschwader 26 headquarters in France. The assessment seemed straightforward. Twin-engine fighters were inherently inferior to single-engine designs in dogfighting. The Messerschmitt Bf-110 Zerstörer had proven this repeatedly over Britain. Heavy, unmanoeuvrable, easy prey for nimble single-engine Spitfires and Hurricanes. The P-38 appeared to suffer the same fundamental flaws, magnified. At over 10 tons fully loaded, it weighed nearly twice as much as a P-51 Mustang. Its twin-boom design created massive drag. The distance between engines meant asymmetric thrust problems if one engine failed. The centerline weapons pod was far from the pilot's natural sightline, creating aiming difficulties. German fighter pilots who saw the first intelligence photographs laughed. The Americans had built a reconnaissance platform, nothing more. Perhaps useful for long-range patrol work, but certainly not a fighter that could challenge the Bf-109 or FW-190 in aerial combat. This assessment would prove catastrophically wrong. November 19th, 1942. Skies over Tunis, North Africa. The morning sun had just cleared the horizon when 18 Lightnings of the 1st and 14th Fighter Groups escorted Boeing B-17 Flying Fortresses toward Tunisian targets. Hauptmann Franz Schiess, leading elements of Jagdgeschwader 53, spotted the American formation at 20,000 feet. His Bf-109G carried the combat experience of 140 missions. He had scored 19 victories against British and Soviet aircraft. Now he would face these strange twin-engine American fighters for the first time. Schiess positioned his unit above and behind the P-38s, standard German tactics for engaging twin-engine aircraft. Attack from astern and above, where the Zerstöre's limited maneuverability made them vulnerable. The Bf-109s dove. What happened next shattered every assumption Schiess had made about twin-engine fighters. The P-38 pilots spotted the diving Germans immediately. Instead of maintaining formation in a defensive posture, they broke hard into the attack. The Lightnings turned inside the diving Messerschmitts with a radius that seemed impossible for such massive aircraft. Schiess found himself looking not at the tail of a lumbering twin-engine bomber-destroyer, but at the nose of a P-38 pulling lead for a deflection shot. 4 50 caliber Brownings and one 20mm Hispano cannon, all mounted on the center line, converged their fire with devastating accuracy. Unlike wing-mounted guns that required convergence adjustment, the P-38's nose-mounted weapons delivered concentrated fire at any range. One burst could saw a Bf-109 in half. Schiess pulled hard, his Bf-109G protesting at the edges of its performance envelope. The American pilot followed, staying inside his turn. Impossible. A 10-ton aircraft should not turn like this. Yet the Lightning stayed with him, its pilot using combat flap settings that transformed the aircraft's handling characteristics. Schiess survived that first engagement, but 3 of his pilots did not return to base. In the following months, he would develop tactics specifically for fighting the P-38, eventually becoming the Luftwaffe's highest-scoring Lightning killer with 17 confirmed victories. But even as he learned to exploit the Lightning's weaknesses, he never stopped respecting its strengths. Years later, after the war, Schiess would write in his combat memoirs that the P-38 pilot who nearly shot him down that first day had taught him a crucial lesson. Never underestimate an enemy based on preconceptions about what their aircraft should be capable of doing. The initial German dismissal of the P-38 stemmed from their experience with the Bf-110. The Messerschmitt Zerstörer destroyer was a twin-engine heavy fighter designed in the late 1930s to escort bombers and destroy enemy bomber formations. It mounted devastating firepower, 4 20mm cannons and 4 machine guns in the nose, plus twin rear-facing machine guns for defence. But during the Battle of Britain in 1940, the Bf-110 had been slaughtered. British Spitfire and Hurricane pilots found the heavy twin-engine fighter easy prey. Unable to dogfight effectively, too slow to run, the Zerstörer units suffered catastrophic losses. By the end of 1940, the Bf-110 had been withdrawn from daylight fighter operations over Britain, relegated to night fighting and ground attack roles. This experience created a doctrine within the Luftwaffe. Twin engine equals vulnerable in air-to-air combat. The assessment seemed validated by every subsequent encounter. Soviet twin-engine fighters proved equally ineffective. French twin-engine designs had been swept from the sky in 1940. Therefore, when the P-38 appeared, German fighter pilots assumed they understood exactly what they faced. Another failed attempt to create a twin-engine day fighter. The assessment reached the highest levels of Luftwaffe command. General Adolf Galland later wrote in his post-war memoir that he initially compared the P-38 to the Bf-110, assuming similar weaknesses. This comparison would prove to be one of the most costly intelligence failures of the German fighter arm. What the Luftwaffe failed to understand was that the P-38 had been designed from the ground up to solve every problem that plagued the Bf-110. The Americans had learned from German mistakes and created something entirely different. February 1937. Wright Field, Ohio. First Lieutenants Benjamin Kelsey and Gordon Saville sat in a cramped office at Army Air Corps headquarters, drafting a specification that would change aerial warfare. They called it Circular Proposal X608, a requirement for a twin-engine interceptor with specific performance goals. top speed of 360 miles per hour at 20,000 feet altitude, service ceiling of 36,000 feet, endurance at economical cruising speed of 1 hour at maximum speed. The numbers seemed impossible. No existing fighter approached such performance. But Kelsey and Saville were not asking for an existing fighter. They were asking for something revolutionary. 5 companies submitted proposals: Consolidated, Curtiss, Douglas, Lockheed, and Vultee. Each design team wrestled with the same fundamental problem. A single engine could not produce enough power to meet the speed requirements. Yet twin engines meant massive weight, drag, and control problems. At Lockheed, a young engineer named Clarence Kelly Johnson led a team that approached the problem differently. Instead of trying to make a twin-engine fighter behave like a single-engine aircraft, they embraced the twin-engine configuration and designed around its unique advantages. Johnson's team examined multiple configurations: push-pull propellers, tandem engines with drive shafts, conventional twin-engine layouts with both engines on the wings. Each design had fatal flaws. Then Johnson sketched a radical concept: place the engines in streamlined booms extending back from the wings. Put the pilot and weapons in a central nacelle between the booms. Use the booms to support twin tail surfaces, creating exceptional stability and control authority. The design offered several revolutionary advantages. The propellers rotated in opposite directions, eliminating torque effects that made single-engine fighters difficult to control. The nose-mounted weapons converged naturally without requiring adjustable gun mounts. The twin-tail surfaces provided redundancy and exceptional control in all axes. The distributed weight improved roll rate despite the aircraft's size. Most importantly, the twin booms created a clean aerodynamic shape that minimized drag. Unlike conventional twin-engine layouts, where engines on the wings created massive interference drag, Johnson's design placed the engines in streamlined nacelles that actually reduced total drag compared to a conventional layout. On June 23, 1937, the Army Air Corps awarded Lockheed a contract to build a prototype, project designation XP-38. Construction began immediately at Lockheed's Burbank, California facility. The prototype rolled out on December 31, 1938. Lieutenant Kelsey, who had helped write the specification, would be the test pilot. On January 27, 1939, Kelsey lifted the XP-38 off the runway for the first time. The test flight revealed an aircraft unlike anything he had flown before. The counter-rotating propellers eliminated torque completely. The tricycle landing gear provided superb visibility during taxi and takeoff. The cockpit, positioned between the engines rather than behind or above them, offered an unobstructed view in all directions. The controls responded crisply despite the aircraft's size. Kelsey pushed the aircraft to 414 miles per hour in level flight, far exceeding the specification requirement. At altitude, with turbo superchargers feeding compressed air to the Allison engines, the aircraft climbed like a rocket. General Henry Arnold, commander of the Army Air Corps, saw the potential immediately. He authorized Kelsey to attempt a transcontinental speed record, flying from Marchfield, California, to Mitchell Field, New York. The flight would demonstrate American air power to the world and prove the XP-38's capabilities. On February 11, 1939, Kelsey took off from Marchfield. He reached Mitchell Field in 7 hours and 2 minutes, including 2 refueling stops. The flight shattered the previous transcontinental record and made national headlines. Then, disaster struck. As Kelsey made his final approach to Mitchell Field, carburetor icing caused both engines to lose power. The XP-38 crashed short of the runway, destroyed. Kelsey walked away uninjured, but the only prototype lay in ruins. The crash could have ended the program. Instead, it validated the design. Kelsey's survival in a crash that destroyed the aircraft proved the inherent safety of the twin-boom layout. The pilot's nacelle remained intact, even though both engine nacelles were demolished. The Army Air Corps immediately ordered 13 YP-38 evaluation aircraft. By the time production P-38s reached combat units in 1942, Lockheed had solved the teething problems that plagued early models. The production aircraft incorporated self-sealing fuel tanks, armor protection for the pilot, improved turbo superchargers, and refined aerodynamics. Most importantly, Lockheed test pilot Milo Burcham had developed combat tactics that exploited the P-38's unique characteristics. Unlike single-engine fighters that relied on tight turning radius, the Lightning used speed, zoom climbs, and diving attacks. The twin-engine power allowed vertical maneuvers impossible in single-engine aircraft. German pilots who first encountered the P-38 in combat had no experience with these tactics. They expected to fight a Bf-110. Instead, they faced something entirely new. The first major shock came over Tunisia. Lieutenant Mark Shipman of the 14th Fighter Group scored the first P-38 kill in North Africa on November 22, 1942, destroying an Italian twin-engine bomber. Over the following weeks, Lightning pilots began engaging Luftwaffe fighters with increasing frequency. German pilots quickly discovered that standard tactics for fighting twin-engine aircraft did not work against the P-38. The Lightning could outturn the Bf-109 G6 at low altitude when properly flown. It could outclimb any German fighter below 15,000 feet. Its diving speed exceeded that of single-engine fighters. Most devastatingly, the P-38's nose-mounted weapons delivered concentrated firepower that destroyed German fighters with shocking efficiency. A 1-second burst, approximately 60 rounds from 450 caliber guns plus 15 rounds from the 20mm cannon, could saw a Bf-109 in half. Franz Stigler, a Luftwaffe ace who would survive the war with 28 victories, encountered P-38s over Tunisia in early 1943. He later wrote about the experience with unusual candor. The Lightning could turn inside us with ease, and they could go from level flight to climb almost instantaneously. We lost quite a few pilots who tried to make an attack and then pull up. The P-38 would simply pitch up and destroy them with that nose-mounted cannon. One cardinal rule we never forgot was to avoid fighting the P-38 head-on. That was suicide. Stigler developed specific tactics for surviving encounters with Lightnings. The best defense was to flick-roll the Bf-109 and dive, exploiting the Lightning's slow initial roll rate. But even this tactic required precise timing. If the P-38 pilot anticipated the maneuver, he could pitch up and catch the diving German with a deflection shot. Johannes Steinhoff, commander of Jagdgeschwader 77 in North Africa, had extensive experience fighting the P-38. His assessment was more nuanced than the initial German dismissal, but equally telling. Steinhoff acknowledged that his unit's Bf-109s were perhaps a little faster than the P-38 in level flight. But he stated unequivocally that a dogfight with the twin-engine fighter was daunting because its turning radius was much smaller. The Lightning could quickly get on the tail of a Bf-109 if the German pilot made any mistake. On August 25, 1943, Steinhoff experienced the P-38's capabilities firsthand in dramatic fashion. He was test flying a Messerschmitt Bf-109G near his base at Foggia, Italy, with his aide Oberleutnant Theo Lindemann flying as wingman. They encountered approximately 140 P-38 Lightnings inbound from North Africa for a surprise attack on German airfields. 2 German fighters against 140 American fighters. Standard doctrine called for evasion. But Steinhoff and Lindemann turned into the formation and attacked head-on. Steinhoff's first burst struck a lightning in the engine nacelle. The American aircraft rolled inverted and the pilot bailed out, landing on the runway at Foggia airfield. Steinhoff continued through the formation, damaging a second Lightning before breaking off. That evening, Steinhoff invited the captured American pilot to his tent for dinner and drinks. They consumed considerable quantities of local wine while discussing aerial combat tactics. The American, Lieutenant Williams, according to United States combat records, provided Steinhoff with valuable intelligence about how American pilots were trained to fly the P-38. Williams explained that the Lightning's greatest advantage was not its speed or firepower, but its versatility. A skilled pilot could exploit the aircraft's unique characteristics to outfly almost any opponent. The twin-engine configuration that German pilots assumed was a weakness was actually the Lightning's greatest strength. If one engine was damaged, the pilot could shut it down, feather the propeller, and continue flying on a single engine. This redundancy proved invaluable over the vast distances of the Pacific Theatre and the Mediterranean. German single-engine pilots who suffered engine damage had one option: immediate forced landing or bailout. Lightning pilots could limp home on one engine, often covering hundreds of miles to reach friendly territory. The twin engines also provided exceptional power for vertical maneuvers. A Lightning pilot being pursued by a German fighter could pull into a steep climb, using both engines to sustain airspeed that would have been impossible in a single-engine aircraft. The pursuing German fighter would stall first, becoming an easy target for the Lightning pilot, who could then roll over and dive on his opponent. Most significantly, the twin-engine layout allowed the P-38 to carry fuel loads that exceeded anything possible in single-engine fighters. With drop tanks, Lightnings routinely flew missions of 8 to 10 hours duration, covering distances of 1,200 miles or more. This range transformed aerial warfare in the Pacific and enabled missions that would have been impossible with single-engine fighters. The most famous demonstration of this range advantage occurred on April 18, 1943. American intelligence officers at Pearl Harbor, Hawaii, decoded a Japanese message revealing that Admiral Isoroku Yamamoto, architect of the Pearl Harbor attack and commander of the Imperial Japanese Navy, would be flying from Rabaul to Bougainville to inspect forward bases. The flight path would take Yamamoto's transport, a Mitsubishi G-4M Betty bomber, over 435 miles of open ocean. The only American aircraft with sufficient range to intercept was the P-38. Major John Mitchell planned the mission with mathematical precision. 18 P-38s from the 347th Fighter Group would fly from Guadalcanal, covering 430 miles at wave-top altitude to avoid radar detection. The entire flight would maintain radio silence. At the intercept point, 4 aircraft would attack Yamamoto's bomber, while 14 provided cover against Japanese fighter escorts. On the morning of April 18th, Mitchell led his formation off the runway at Cookham Field, Guadalcanal. For the next hour and 50 minutes, 18 Lightnings flew 30 to 50 feet above the Pacific, their pilots navigating by dead reckoning across hundreds of miles of empty ocean. At precisely 0934 hours, exactly as American intelligence had predicted, Mitchell spotted 2 Betty bombers escorted by 6 Mitsubishi, a 6M0 fighters approaching Bougainville at 6,000 feet altitude. Captain Thomas Lanphier and Lieutenant Rex Barber broke from the formation and attacked. Lanphier engaged the Zero escorts while Barber closed on Yamamoto's bomber. A 2-second burst from 450 caliber guns and 120mm cannon tore the Betty's wing off. The aircraft crashed into the jungle, killing everyone aboard, including Admiral Yamamoto. The mission succeeded only because the P-38 possessed the range and reliability to fly 870 miles over open ocean, engage in combat, and return safely to base. No other American fighter could have accomplished this feat. German intelligence officers analyzing the mission noted with alarm that the United States possessed a fighter with greater range than many German bombers, but the lessons of the Yamamoto mission did not filter down to German fighter pilots quickly enough. Throughout 1943, Luftwaffe pilots continued to underestimate the P-38, with predictable results. On April 5, 1943, 26 P-38Fs of the 82nd Fighter Group engaged German and Italian fighters over North Africa. The Americans claimed 31 enemy aircraft destroyed for minimal losses. The 82nd Fighter Group earned the nickname from captured German pilots, the fork-tailed devil, a grudging acknowledgement of the Lightning's effectiveness. However, the reliability of this nickname remains questionable. No German combat reports from that period mention using such a term. The phrase may have been invented for American propaganda purposes. What is certain is that German pilots developed healthy respect for the Lightning's capabilities, even if they never called it the fork-tailed devil in their own language. Franz Schiess, who would become the Luftwaffe's leading Lightning killer, shot down his first P-38 over the sea south of Sicily on May 21, 1943, his 50th victory. By this time, Schiess had developed specific tactics for exploiting the P-38's weaknesses. The Lightning's initial roll rate was slow in the first 10 degrees. A German pilot under attack could flick roll and pull into a hard turn, using the brief moment before the P-38 could match the maneuver to create separation. If attacked head-on, the German pilot's only option was to brake hard and dive, using superior diving speed to escape. But Schiess also documented the Lightning's strengths in his combat reports. The aircraft was faster than his Bf-109G6 in level flight below 20,000 feet. It could outclimb German fighters at low altitude. Its nose-mounted weapons were devastatingly effective, and it was nearly impossible to destroy from behind because the engines and tail booms absorbed damage that would have downed a single engine fighter. On September 2, 1943, Schiess led a scramble against United States Army Air Force's B-25 Mitchell bombers attacking rail marshalling yards at Cancello near Naples. His unit engaged the P-38 Lightning escort. In the fierce battle that followed, German pilots claimed 10 Lightnings destroyed. But Schiess's Bf-109G6, Werk number 160022, crashed into the Mediterranean 30 to 50 kilometers southwest of Ischia in the Gulf of Salerno. Schiess was 22 years old. He had scored 67 victories in 657 combat missions. 17 of those victories were P-38s, making him the highest-scoring Lightning killer in the Luftwaffe. But even this experienced ace, who had developed tactics specifically for fighting the P-38, fell to the Lightning's guns. The irony was not lost on surviving German pilots. The twin-engine fighter they had initially dismissed as inferior had destroyed their highest-scoring specialist in combat against it. Kurt Bühligen, third highest-scoring German fighter pilot on the Western Front with 112 victories, later recalled his experiences fighting P-38s in North Africa. Once in Africa, we were 6 and met 8 P-38s and shot down 7. The P-38 fighter and the B-24 Liberator were easy to burn. But Bühligen's assessment revealed more complexity than simple dismissal. He acknowledged that, properly flown, the P-38 was dangerous. The 7 victories he described came against inexperienced American pilots who made tactical errors. Against veteran Lightning pilots who understood their aircraft's capabilities, the outcome was very different. By late 1943, German pilots had developed a comprehensive understanding of the P-38's strengths and weaknesses. Intelligence officers compiled detailed reports on how to fight the Lightning effectively, attack from above and behind when possible, using superior diving speed to avoid engagement if the Lightning turned into the attack, never engage in head-on attacks. The concentrated nose-mounted firepower gave the Lightning overwhelming advantage in such encounters. Avoid turning fights at low altitude where the Lightning's superior power-to-weight ratio provided advantage. If caught in a turning engagement, flick roll and dive immediately, rather than trying to outturn the P-38. Use the Bf-109's superior diving performance to escape if overwhelmed. The Lightning suffered from compressibility problems in steep dives that limited its ability to follow. Most importantly, never assume the P-38 is an easy kill because it has 2 engines. That assumption had already cost too many German pilots their lives. But even as German pilots learned to fight the Lightning more effectively, they faced a new challenge. Improved versions of the P-38 were reaching combat units with capabilities that exceeded earlier models. The P-38J, which entered service in August 1943, incorporated numerous improvements. Most significantly, it featured hydraulically boosted ailerons that dramatically improved roll rate. The slow initial roll response that German pilots had learned to exploit largely disappeared. The P-38J also featured dive flaps that could be deployed at high speed to prevent compressibility. Previously, Lightning pilots had been reluctant to follow German fighters into steep dives because control forces became prohibitively high as the aircraft approached transonic speeds. With dive flaps, P-38 pilots could follow diving German fighters all the way to the ground. Later, P-38J models incorporated improved cockpit heating. Earlier Lightnings suffered from notoriously cold cockpits in the high-altitude environment of European combat. At 26,000 feet over Germany, pilots shivered in bitterly cold cockpits. Their hands and feet became numb with cold and in some instances frostbitten. Not infrequently, a pilot was so weakened by conditions that he had to be assisted out of the cockpit upon return. The heating problem stemmed from the cockpit's position between the engines rather than behind them. Warm air had to be ducted from the engines out on the wings, and the system provided minimal heat. The improved heating in later models solved this problem, making the Lightning more effective in European operations. Despite these improvements, the P-38 never achieved the same level of success in Europe as in the Pacific and Mediterranean theatres. Several factors contributed to this disparity. Combat in Europe typically occurred at altitudes above 20,000 feet, often exceeding 30,000 feet. At these altitudes, the Lightning's Allison engines, even with turbo superchargers, could not match the performance of Rolls-Royce Merlin-powered P-51 Mustangs or late-model German fighters. The North American P-51 Mustang, which began arriving in large numbers in early 1944, offered superior high-altitude performance, greater range, and simpler maintenance. The Mustang got 3.3 miles per gallon, while the Lightning got less than 1.8. This fuel efficiency gave the Mustang a combat radius of more than 700 miles, enough to escort bombers to any target in Germany. By summer 1944, Lightning units in Europe were being re-equipped with Mustangs. The 55th Fighter Group, which had flown P-38s since October 1943, converted to P-51Ds in July 1944. Pilots expressed mixed feelings about the transition. They appreciated the Mustang's performance advantages, but missed the security of two engines and the Lightning's stability as a gunnery platform. Robin Olds, who became the last P-38 ace in the 8th Air Force, later reflected on his experience flying both types. Flying a P-38J, he downed 5 German fighters on 2 separate missions over France and Germany. He subsequently transitioned to P-51s and scored 7 more kills. After World War II, he flew F-4 Phantom IIs in Vietnam, ending his career as Brigadier General with 16 kills. Olds stated that the P-38 was an excellent aircraft for experienced pilots who understood its strengths and limitations. The twin engines provided redundancy and power that single-engine fighters could not match. The nose-mounted weapons delivered devastating firepower, but the aircraft required more skill to fly effectively than the P-51, and its maintenance demands were higher. In the Pacific theatre, where combat occurred at lower altitudes and range was paramount, the P-38 continued to dominate. The 2 top-scoring American aces, Major Richard Bong with 40 victories and Major Thomas McGuire with 38, flew only P-38s. Both scored all their kills against Japanese aircraft. Bong, who survived the war only to die testing a P-80 jet fighter in August 1945, exemplified the aggressive tactics that made Lightning pilots successful. He stated frankly that he was a poor shot, so he closed to point-blank range before firing, sometimes flying through the debris of aircraft he destroyed. This tactic exploited the P-38's structural strength. The twin-boom design distributed stress across multiple load paths. Damage that would have destroyed a single-engine fighter often left the Lightning flyable. Pilots returned to base with one engine shot out, tail surfaces shredded, and holes throughout the airframe. The redundant control surfaces and engines kept them alive. Japanese pilots, like their German counterparts, initially underestimated the P-38. Saburo Sakai, a Japanese ace with 64 victories, wrote in his post-war memoir that the P-38 first used in combat against Zeros appeared to lack any distinctive features other than speed at great altitudes and very high diving speed. Japanese pilots delighted in the early encounters where American pilots attempted to dogfight with Zeros, but Sakai noted that it quickly became obvious the Americans had not yet learned the most favorable characteristics of the P-38. Once American pilots stopped trying to turn fight and instead used boom and zoom tactics, the situation changed dramatically. Sakai wrote that pilots were too often heard cursing the speedy P-38s which flaunted their flashing performance. The P-38 was in a most enviable position. He could choose to fight when and where he desired and on his own terms. Under such conditions, the Lightning became one of the most deadly of all enemy planes. The lessons Sakai drew from fighting the P-38 paralleled conclusions reached by German pilots. The only possible means of commencing major combat at a desired moment is through the possession of aircraft superior to those available to the enemy. In other words, the P-38's greatest advantage was not speed or firepower or maneuverability in isolation. It was the combination of capabilities that allowed its pilot to dictate the terms of engagement. The twin-engine design that had initially seemed like a weakness proved to be the key to this flexibility. By late 1944, as Allied forces closed in on Germany from east and west, Luftwaffe fighter units faced overwhelming odds. American bomber formations appeared over German cities daily, escorted by swarms of fighters. P-38s, P-47s, and P-51s contested every cubic meter of German airspace. German pilots who had learned to respect the P-38 in 1943 now faced it in numbers they could not counter. The 8th and 9th Air Forces deployed hundreds of Lightnings for ground attack missions, bombing and strafing German transportation networks. The distinctive twin-boom silhouette became synonymous with American air power. Herbert Kaiser, who eventually scored 68 victories, shot down his first P-38 in January 1943. He later stated that the P-38 should be respected as a formidable opponent, that it was faster and more maneuverable than the Bf-109 G6 model he flew, especially since the G6 was slowed by underwing armament. Johann Pichler, who encountered P-38s over Italy in 1943, found them faster in climbs than his own aircraft. The testimony from German pilots consistently acknowledged the Lightning's capabilities, even as they claimed victories against it. The statistics reveal the complexity of the P-38's combat record. In the Mediterranean theatre, where the Lightning suffered its highest losses, combat conditions favoured German tactics. Many engagements occurred when P-38s were tied to close bomber escort duties, making them vulnerable to attack from above by German fighters who selected the most advantageous position and timing. On August 25, 1943, 13 P-38s were shot down in a single sortie by Jagdgeschwader, 53 Bf-109s without achieving a single kill. On August 30th, 13 more fell to German and Italian fighters. On September 2nd, 10 P-38s were shot down in combat with Bf-109s of JG-53, though this engagement also cost the Germans 4 Bf-109s, including Franz Schiess. These one-sided defeats stemmed from tactical doctrine rather than aircraft limitations. When American commanders changed tactics in late 1943, allowing P-38 pilots to engage aggressively rather than staying tied to bombers, the results improved dramatically. Overall, P-38 pilots in all theatres claimed approximately 1,900 enemy aircraft destroyed. Losses totaled approximately 1,300 Lightnings from all causes, including accidents and ground fire. The kill-to-loss ratio, while not matching the P-51 Mustang's performance, demonstrated that the twin-engine fighter was far from the easy prey German pilots had initially assumed. The legacy of the P-38's combat performance forced a fundamental reassessment of twin-engine fighter design. Before the Lightning, conventional wisdom held that twin engines inevitably meant inferior dogfighting capability. The P-38 proved this assumption wrong when the design properly exploited the advantages twin engines provided. Post-war analysis by both American and German aviation experts identified several key factors that made the P-38 successful, where previous twin-engine fighters had failed. First, the unconventional twin-boom layout minimized drag and created excellent weight distribution. Unlike conventional twin-engine designs, where engines on the wings created massive interference drag and asymmetric thrust problems, the Lightning's streamlined nacelles and counter-rotating propellers largely eliminated these issues. Second, the concentrated nose-mounted armament provided devastating firepower without the complexity of synchronized wing guns. A skilled P-38 pilot could destroy enemy aircraft at ranges where wing-mounted guns would have been ineffective due to convergence issues. Third, the twin engines provided redundancy and power that transformed combat tactics. Lightning pilots could absorb battle damage that would have downed single-engine fighters and continue fighting. They could sustain vertical maneuvers longer than any single-engine opponent. Most importantly, they could fly missions of duration and distance impossible for single-engine aircraft. Fourth, the Lightning's forgiving handling characteristics made it accessible to pilots who had trained primarily on single-engine aircraft. While it required skill to exploit fully, the P-38 did not demand the specialized training that made other twin-engine fighters difficult to master. German aviation engineers studied captured P-38s extensively, hoping to replicate the design's success. But by the time they fully understood what made the Lightning effective, Germany lacked the resources to develop competing designs. The Messerschmitt Me 262, Germany's jet-powered twin-engine fighter, incorporated some lessons from the Lightning, but arrived too late and in too few numbers to affect the war's outcome. The assessment of the P-38 by German pilots evolved dramatically over 30 months of combat. Initial dismissal gave way to cautious respect, then genuine concern as American pilots learned to exploit their aircraft's advantages. By war's end, German fighter pilots who had survived encounters with P-38s offered nuanced evaluations that acknowledged both strengths and weaknesses. They noted that while the Lightning could be defeated by exploiting its vulnerabilities, doing so required skill, experience, and favorable tactical circumstances. Against veteran American pilots who understood their aircraft, the P-38 was deadly. The transformation in German attitudes toward the P-38 paralleled their broader realization about American air power. The Americans were not building inferior aircraft flown by inexperienced pilots. They were developing weapons systems optimized for specific missions and training pilots to exploit every advantage their aircraft offered. The P-38 exemplified this approach. It was not designed to outturn a Bf-109 or FW-190. It was designed to fly farther, climb higher, hit harder, and survive damage that would destroy single-engine fighters. Within those parameters, the Lightning excelled. By May 1945, when Germany surrendered, the P-38 had been largely phased out of frontline service in Europe, replaced by the superior P-51 Mustang. But in the Pacific, Lightnings continued flying combat missions until Japan's surrender in August. The final accounting showed 10,037 P-38s built. Approximately 1,900 enemy aircraft claimed destroyed. Countless reconnaissance missions flown deep into enemy territory. Strategic strikes against targets beyond the range of any other fighter. The assassination of Admiral Yamamoto. These achievements validated the design decisions that German pilots had initially ridiculed. The top American ace, Richard Bong, flew only the P-38. The second highest scoring American ace, Thomas McGuire, flew only the P-38. The third-ranking ace in the Pacific, Charles MacDonald, scored 27 kills in his P-38 named Put Put Maru. These men proved that in capable hands, the twin-engine Lightning was as deadly as any fighter in the sky. German pilots who survived the war and later emigrated to the United States often encountered P-38s at air shows and museums. Their reactions revealed the respect that combat experience had taught them. Franz Stigler, the ace who had advised pilots to never engage the P-38 head-on, visited the National Museum of the United States Air Force in Ohio in 1986. He stood before the museum's Lightning for nearly an hour, examining the nose-mounted weapons, the twin booms, the tricycle landing gear. A museum volunteer asked what he thought of the aircraft. Stigler responded that it was the most innovative fighter design of the war. He acknowledged that German engineers had been too conservative, too committed to conventional layouts. The Americans had been willing to try something radical, and it had worked. Johannes Steinhoff, who had shot down 4 P-38s in a single engagement over Italy, later stated in a post-war interview that he considered the Lightning the most dangerous Allied fighter he faced. This assessment surprised many, given that Steinhoff had also fought against Spitfires, Mustangs, and Soviet fighters. But Steinhoff explained that the P-38's combination of range, firepower, and survivability made it uniquely threatening. A Spitfire or Mustang might shoot you down in a dogfight, Steinhoff noted, but the P-38 could be anywhere, strike from any direction, absorb your return fire, and escape to fight again. That versatility made it more dangerous than single-engine fighters with superior performance in specific parameters. The lesson German aces learned about the P-38 extended beyond aviation. They had assumed that American engineering and tactics would follow conventional patterns. When the Americans introduced innovations like the Lightning's twin-boom design, German pilots initially dismissed it as naive experimentation. Combat revealed the error in this thinking. The Americans were not naive. They were approaching aerial warfare from different assumptions, willing to try unconventional solutions if those solutions provided tactical advantages. This willingness to innovate, to build aircraft optimized for specific missions rather than following conventional formulas, characterized American air power throughout World War II. The P-38 was simply one example, albeit a particularly striking one. By the time German pilots fully appreciated what the Lightning represented, Allied air superiority was complete. The skies over Germany belonged to American and British aircraft. The Luftwaffe's most experienced pilots were dead, captured, or grounded by fuel shortages. The twin-engine fighter they had once laughed at was now destroying German transportation networks with impunity. In the final analysis, the P-38 Lightning accomplished exactly what its designers intended. It provided the United States Army Air Forces with a fighter capable of missions impossible for single-engine aircraft. Its unconventional design, initially ridiculed by German pilots, proved to be revolutionary rather than foolish. The twin engines that seemed like a fatal weakness were actually the Lightning's greatest strength. They provided redundancy, power, range, and survivability that transformed aerial combat tactics. German aces learned this truth through bitter experience, one engagement at a time. Some lessons can only be learned through combat. For Luftwaffe fighter pilots in 1942 and 1943, the P-38 Lightning taught one of the war's hardest lessons. Never underestimate an enemy based on preconceptions about what their weapons should be capable of achieving. The twin-boom fighter that violated every principle of German fighter design doctrine proved devastatingly effective in the hands of skilled American pilots. The mathematics of this effectiveness were written not in theoretical performance specifications, but in combat records that could not be denied. By war's end, no German pilot dismissed the P-38 as an easy kill. They had learned to respect the Lightning's capabilities through the most unforgiving teacher available: combat experience. The story of the P-38 Lightning stands as testament to innovation's power in warfare. Lockheed's designers had created something genuinely new, an aircraft that solved problems in unconventional ways. German pilots, who initially laughed at photographs of the strange twin-boom fighter, eventually developed tactics specifically for fighting it, acknowledging its strengths even as they sought to exploit its weaknesses. Those German aces who survived the war often reflected on their encounters with the Lightning. Some, like Franz Stigler and Johannes Steinhoff, wrote extensively about the aircraft in post-war memoirs. Others shared their experiences in interviews decades after the conflict ended. Their testimony consistently revealed a progression from dismissal to respect. The P-38 had earned its reputation through combat performance that forced even the Luftwaffe's best pilots to revise their assumptions about twin-engine fighters. In the end, the Lightning accomplished something more significant than accumulating victory tallies. It proved that unconventional designs could succeed if they properly exploited the advantages their configuration provided. The twin engines that German pilots assumed were a liability proved to be a deadly advantage. That lesson shaped fighter design for decades after World War II ended. Twin-engine fighters like the F-4 Phantom II, F-14 Tomcat, and F-15 Eagle trace their lineage back to principles the P-38 demonstrated. Power, range, survivability, and weapon load matter more than adherence to conventional single-engine layouts. German pilots who underestimated the P-38 learned this truth the hardest way possible. In combat, against an enemy who understood how to exploit every advantage their aircraft offered. The distinctive twin-boom silhouette that seemed so strange in intelligence photographs proved to be the shape of aerial warfare's future. The Lightning's thunder echoed across 3 years of combat, from Iceland to Tokyo. And in that thunder, German aces heard a message they could not ignore. Innovation wins wars. Conventional thinking loses them. They had underestimated the P-38 Lightning. Then they realized its twin engines were a deadly advantage. The realization came too late to change the outcome, but it transformed their understanding of what was possible in aerial combat. The strange American fighter with 2 engines and twin booms had rewritten the rules, and German pilots paid the price for assuming those rules could never change.